Hi there, just want to do a quick video to show the latest development in my Reflow soldering oven project. This is in an effort to get Lebowski brain boards built, so here is 200 or so brains for a microcontroller that my late friend Bob Carter designed. And it's been my mission over the last year or so to try and realise that project and see it through. So they're little surface mount things. They're a couple of stencils, and we need a reflow oven to basically solder these all together. I mean, Bob did one by hand, but doing them all soldering by hand and that fine pitch stuff, it's not for batch production. So this was my first attempt. That was a £6 toaster oven I got off eBay, second hand. Never really used, but one problem with it is it just didn't get hot enough to get to the top of the curve. So I kind of got shot in the foot straight away. And that is supposed to be a solid state relay, which I don't know whether I bought a cheap one and it just didn't work, but what happened is it always let the power through. So no matter whether the light was on or off, it was always letting power through. It didn't stop that thing from turning on, which is a bit pointless, you know. That doesn't really help when you're trying to control the heat. You need something that goes fully on or fully off, or even somewhere in between. You could do a PID loop. But anyway, I then found a website run by a chap called Andy Brown in the UK, and he put me on to using this kind of a toaster oven and putting foil around it, because again, it doesn't necessarily get up to the right temperature, but if you put foil inside, which is a wife's suggestion, you retain a bit more heat. And it does get up to the kind of 215 degrees C that you need at the peak of the heat curve. So that was the setup as of last night. I've got the gear here in front of me on a prototyping board, and that's an SCR and a stepper motor, so a dimmer switch essentially for that 3-pin plug. And I didn't take any video last night, so I'm just doing this video now to show that it does work. And what I did do last night was, so we can see that this was my first attempt, and that was with the toaster oven, which that's what happens in a toaster oven when it doesn't have any control. That is just a by chance line happens to correlate with that part of the loop, but it doesn't do anything else, and it doesn't reach the peak that it needs to. So I had to bin that, and that was the first toaster oven. First of the graphs last night was after a lot of unsuccessful runs, so the oven was still hot, so it wasn't starting down here and it's starting up here, and so you can see it didn't switch on until the temperature dipped below the target temperature, and then it struggled to keep up and it overshot a bit, and then it managed to follow and oscillate around the line quite nicely. And at the top here, basically you've got what happens is you kind of need to take the lid off. There's no way to cool the oven down other than, I guess maybe you could run the fans hard if you hacked it apart. I mean, I'm trying to not do anything per se to the oven so that at the end of this I can still use it as an oven. Mind you, I'll have been reflowing lead, so probably won't. Anyway, that was the first attempt, and then about an hour later I just reran it, and that is the second attempt. So you can see it started off colder, did it again, and at that point I just took the lid off and let it cool down, and so I didn't get I kind of disrupted the temperature probe at that point, so I didn't get any decent data after that point, which is why it's not shown. But anyway, in principle that's the reflow curve. That should help me solder these surface mount parts to the boards. So, and prior to this, I had, I don't know if you can see that, but I tried to output the kind of the data onto the instead of using the serial, just use a Nokia screen. But they are notoriously flaky, and it's because I wasn't logging the data, it was hard then to produce a graph, which was nice to see. But it would be nice to run this standalone without having to have a computer on nearby. Anyway, so how does it work? Go to the code. This is not all my code. I've had to manipulate a lot of this to and shove stuff together from different places. So Tom Igo wrote like a stepper header example, and I've stolen that. It only goes one way, clockwise, so you have to initialize 2 steppers and flip the pins around, which is like it's kind of like swapping the wires on the motor, but in virtual sense, and that makes it go anti-clockwise. And then yeah, so obviously turning heat on is turning the dimmer one way, and then turning it off again is turning it the other. So I've kind of got it turning with this for loop, a delay to let it actually do that thing, because if you don't have the delay and it goes on, it for some reason doesn't complete the stepping. And some serial output to tell me that it's actually turned it off, because otherwise you kind of, it's good for debugging anyway. This is the kind of profile for the time. It sort of dictates what that blue line in the graphs was. This is using that to sort of calculate that profile, I guess. It's producing the time, the target temperature given a time t. But if you wanted to change the profile of that curve, you'd change the array that's up here instead. This is just code that runs through the array and spits you out a value given a time. Here's just a setup. I heat on and heat off just once so that I know that the heater is off to start with. I guess I could have just heated off, but it's always nice to. I tend to leave it off, and then it just lets me know that the loop has started when I'm looking at it. This is just now into the loop of the Arduino program. So there's a setup and a loop, and the loop just runs all the time after the setup, and reads the temperature off the thermocouple. It finds the target temperature given the time and puts it in TG. It just then goes of is my target temperature greater than my temperature? If it is, I need to be heating, and if not, I don't want to be heating. And then this is kind of I want it to make sure that so this is what we call a ternary. So the way this works is evaluate that bit, and if that evaluates true, then you do this thing, which is saying that assign that true, else assign it false. So it's like an if-else, but in one line, and it's always an assign. It's not always assign, but in this case it is. And then make sure that the heating, because this is this state, and set it to the previous state, so you've got a previous state in the next loop. Then you only want to do something if you need to. So this is why checking that the heating state is changed here from what it used to be. So if it has changed and we need heating, let's turn it on, and else let's turn it off again. And then they're just a load of serial output. Turn it off, and then, as I say, this wasn't all my code. This is something else that somebody else wrote. Anyway, it's not PID, it's just on-off, and that's what produces those graphs. But if I turn the serial monitor on, so go serial monitor, and it's already run a loop, so we'll close that and reopen it, because doing that resets the Arduino. So there you go, it's first line, target temp thingy, and then that's turning off again. So that was heat on and heat off, and then what it'll do is try and heat off again, because it's the first thing it does is realize that the target temperature is or rather the temperature is higher than the target. So, and now you can see it's heated on, which has meant that it's all the way clockwise, and it won't do anything else now, because essentially the room's not going to get, well, I say it won't do anything else. the room's not going to get any hotter because I've not got a halogen oven on the thermocouple. But at the end of this, it will, about 4 minutes time, it will drop the temperature away and so it'll turn it off. But I'm not going to sit here and do all that with you. But I hope this is interesting to some people. For me, I'm doing this because I can't afford to get these things fabricated in any other way, and I want other people to be able to use Bob's work and a chap called Lebowski's work. So anyway, that's all for now. Thanks for watching.